Hi guys, and welcome to another video, and today we're going to be looking at the continuation of inverse functions at grade 12 level. And in our last lesson we basically looked at the parabola. Well, in this lesson we're going to be looking at the inverse of an exponential function, which gives us a log function, and the inverse of a log function, which will give us an exponential function. So let's get straight into it. First of all, let's revise. What is a function? A function is defined by saying that for every x value we need to have a unique y value. Now, we've looked at examples of functions already. We looked at a straight line function or a straight line graph, and we've looked at a parabola. Now we're going to be looking at an exponential function. So let's look at that very quickly. So an exponential function that we're going to be looking at is going to be in the form y equals to b to the x. So let's look at that very quickly. So let's look at some theory. So here, if we look at y equals to b to the x, now there's two types of graphs that we can get. We can get a graph for where b is greater than 1, and if b is greater than 1, we're going to get a function or a graph which looks like that, and we say that that is an increasing function. As you can see, as the values of x increase, so too does the values of y. But also, on the topic of increasing functions, remember that one of the topics that we will be looking at this term is calculus. And remember that in calculus, if we draw a tangent to this particular curve, then the tangent that will be drawn to this particular curve will have a positive gradient, and therefore the function will be increasing for all values of x, because we'll only be able to draw tangents with positive gradients to this particular curve. So just remember that if your gradient is positive, your function is increasing. If your gradient is negative, your function will be decreasing. So learners, now let's look at, so if b is greater than 1, our function will look like that. If b is between 0 and 1, then my function is going to be a decreasing function, which is going to look something like that. So as you can see, as the values of x now increases, the values of y will decrease. And once again, speaking about what I spoke about a little earlier, if I try to draw tangents to this particular curve, all the tangents will have a negative gradient, and meaning that it will decrease for all values of x. And remember, how does positive gradient tangents or lines look? Remember, if m is greater than 0, your line is going to go in that direction. Okay, and if m is less than 0, if your gradient is negative, then your line will look like that. Okay, so once again, if your gradient is positive, your function will increase. If your gradient is negative, your function will decrease. So getting back to this exponential function in the form y equals to b to the x, if b is greater than 1, we're going to have an increasing function. If b is between 0 and 1, we'll have a decreasing function. Just take note of the shapes for now. So let's look at our log function. So what happens now when we have the inverse of an exponential function? Well, when we have the inverse of an exponential function, so let's look at the first one here, the inverse of this particular function here. So let's look at another color, and if we look at the inverse of this particular function where b is greater than 1. Now remember that firstly, for an exponential function, if you look very carefully, you'll see that the x-axis is the asymptote. So if the x-axis is the asymptote, that means that the asymptote for this particular function is y equals to 0. So for the inverse function, remember now that the asymptotes are going to be swapped around. Now, if the asymptote is swapped around, it means that for the inverse function is going to have an asymptote at the y-axis, which is at x equals to 0. So if you look very carefully, the inverse function is going to look something like that. So that's f inverse. So once again, learners, if you have to look at it here, if this is my function f, where b is greater than 1, this is going to be the inverse function f inverse. And I'm going to come to how to write it in a moment. Now let's look at the following. So once again, if I look at this particular function, an exponential function, if b is negative, or rather if it's between 0 and 1, okay, if b is between 0 and 1, remember b can't be negative, then the inverse function is going to look like this. So that's f inverse, and that will be f. Now that we know that this is an exponential function and this is going to be a log function, let's get to how we go about writing it. Okay, we'll come back to the topic of reflections a little bit later on. So let's look at that very, very closely. Now, so if you have to look at, if I have a function f, and if the function is y is equal to b to the x, then what do we say f inverse is? F inverse, remember that with functions and inverses, all we do is we swap the x and y values around. So this will be x equals to b to the y. Now herein lies a problem. Now the problem is that we are required to write our functions in terms of y. So therefore, because y is in the exponent, that is why we require that log function, right? So the log function now will look as follows. It will be y equals to log of x base b. So now we can formulate a rule from this. So the rule is very simple. If x is equal to b to the y, then y is going to equal to log of x base b. Now let's look at what if we are given the function in terms of logs. Y equals to log of x with base b. Now what happens if we are going to write the inverse of a log function? So now the inverse of a log function, now you've got to pay careful attention to this. So the first thing that we're going to do is we're going to get rid of this log by expressing y equals to log b as an exponential function, which will be x equals to, so what we say is that this b just basically knocks this y up here, so it'll be b to the y. So y equals to log of x with base b is equal to x equals to b to the y. It's the same thing. Now for f inverse, remember for the function and its inverse, we just swap the x and y values around. So if you swap the x and y values around, what will you have? Y and x get swapped around, so it'll be b to the x. So y equals to b to the x. So as you can see, there's your exponential function, there's the log function. There's the log function, there's your exponential function. So the inverse of an exponential function is a log function, and the inverse of a log function is an exponential function. And now I told you how to basically get it. Now, the next thing that I would like you to look at is the concept of reflections. If you have to look at this here, f, where b is greater than 1. Remember, if b is greater than 1, your function is going to be increasing and it's going to look like that. If b is between 0 and 1, your function is now going to be decreasing and look like that. If you look at these two curves, the black ones here, you'll be able to see that those two curves are reflected about the y-axis. So there is a reflection in the y-axis. And if you look at these red curves here, this one here on top and this one in the bottom, you'll be able to see that they are reflected about the x-axis. So there is a reflection about the x-axis. So once again, that is just basically a little bit of theory when it comes to exponential functions and their inverses, which is a log function. Learners, that is the theory. So now let's try and apply this particular theory. Remember, I always tell you that these videos are a supplement to your learning. Make sure that you form a summary from your notes first and learn that particular summary before you're going to do any application. Now let's look at some application. Before we do that, let's just look at what we are required to do from our work schedule. Determine and sketch graphs of inverse functions. We're going to do that today. We're going to be looking at the concept once again, domain and ranges, asymptotes. So we've been looking at all of that I've explained to you, and the log function and so on. Okay, and sketching of graphs and their inverses. Let's look at the first question, which is from a past examination paper, and I think this came out in 2010 if I'm not mistaken. So the graph of f of x equals to 3 to the x is drawn below. So this is the graph of f of x equals to 3 to the x. Let's see what they're asking us to do. So in the first question they're saying write f inverse in the form y. So to write f inverse in the form y, so we are given an exponential function. Remember here b is greater than 1, so it's an increasing function. Now let's write the inverse of that particular function. So what will we do in this particular instance? So for 7.1, firstly let's write down what f is in terms of x and y. So f will be y equals to 3 to the x. So what is the inverse function? F inverse, what do you do? Well, the concept of inverse functions, remember once again, for a function and its inverse, it's reflected about the line y equals to x, which means that we're just swapping the x and y values around. Transformation geometry. So x equals to 3 to the y. Now remember that we are required to write our answer in terms of y. So therefore we have to now use our log function, which now will be y equals to log of x with base 3, and that's our solution. Y equals to log x base 3. That's 7.1 done. 7.2, sketch the graphs of y equals to f inverse x and f inverse of x minus 2 on the grid provided in the diagram sheet. So let us go look at sketching these particular graphs. So the first thing that we are required to do is to sketch f inverse of x. So let's sketch that first. So f inverse of x. Now if you look at f of x, and we are now required to sketch f inverse of x, so we are given the graph of f of x. So let's look at this particular graph. So there's our Cartesian plane, y-axis and x-axis. What's this coordinate here? This coordinate is 0 and 1. As you can see, if I put 3 to the 0, I'll get 1, so x value, y value. And here, this is x equals to 1 and y is equal to 3. So here we got 1 and 3. So when x is equal to 1, y is equal to 3. And as you can see, if you substitute x equals to 1 here, you get 3 to the 1 is equal to 3. Now remember, what do we do when we want to sketch the inverse function? Well, all we need to do is just swap the x and the y values around. So let's draw this graph in the color red. So therefore we'll have 1 and 0 if we swap this coordinates around. So 1 and 0, and 1 and 3 becomes 3 and 1. So 1, 2, 3, and 1 would be there. So that would be 3 and 1. Now remember that your graph of y equals to, or f of x equals to 3 to the x has an asymptote, your x-axis. So the asymptote is basically the x-axis, which is this. So the equation of the asymptote is y equals to 0. Therefore, for the inverse function, the asymptote is going to be the y-axis. So one important thing for you to remember as well is that the asymptotes also get swapped around. So the asymptote of your inverse function when dealing with exponential functions and the inverses, which is the log function, is the asymptotes also get swapped around. So your asymptote is going to be x equals to 0 for your inverse function. Therefore, when you're drawing this graph, make sure that it does not touch the y-axis, which we write as an equation x equals to 0. It's going to look like this. Okay, so therefore we have our function now, which is drawn, and this function here is f inverse of x. Now let's look at the next function that we are asked to sketch. So the next function that we are asked to sketch is f inverse of x minus 2. Now let's look at a different color to sketch this one. So f inverse of x minus 2. Now what is x minus 2? X minus 2 means that your graph of f inverse x is going to shift 2 units to the right. Remember, x minus 2 means that the graph is going to shift 2 units to the right. So what does that mean, learners? It means that every coordinate now is going to move 2 units to the right. So for 1 and 0, we'll now have, if we have to shift it 2 units to the right, 1, 2. So therefore this will be 3 and 0. And this coordinate here, which is 3 and 1, would now become, if you shift it 2 units to the right, will be 4, 5 and 1. So this coordinate here will be 5 and 1. And what else will shift? Well, if you look carefully, remember that our asymptote for our inverse function was the y-axis, which is x equals to 0. So therefore the asymptote would also shift 2 units to the right, and we would now have an asymptote at this particular coordinate here, or this line over here would be our asymptote. So it would be 1, 2. So our asymptote will be there. So what's important for us to take note of? Let's draw that again. Our asymptote will be here at x equals to 2. So you're going to have an asymptote at x equals to 2. And let's draw that particular graph, and it's going to look as follows. And this is now your graph of f inverse of x minus 2. Right? So basically it's this curve of f inverse of x shifted 2 units to the right. Learners, remember that we must make sure that we draw these as accurate as we possibly can on the diagram sheet which is provided for us. Okay. Now, so for 7.2, we'll simply write in our answer book SDS, which means see diagram sheet. Okay, so let's look at the next question. In the next question, it says use your graphs to solve for x if log of x minus 2 base 3 is less than 1. So for 7.3, it says use our graphs to solve for this particular question. So where is this function f inverse of x less than 1? That's basically what they're asking us for. Where is f inverse of x less than 1? So less than 1 means it's going to be here. So lucky we got these right, this coordinate, because as you can see, it's now going to be for which x value? That x value is 5. And remember now that this line here is at x equals to 2. Remember that this graph f inverse of x minus 2 is not going to touch this line here, because this black line here that I've drawn is our vertical asymptote. Now, so therefore it will be between 2 and 5. So just by looking at the graph, you are able to say that x must be greater than 2 and less than 5. Now looking at an alternative way in which you could do this possible solution, you could say that log, write down the question, log 3x minus 2, log of x minus 2 base 3 less than 1. So we could say x minus 2 is less than, remember the 3 will bump the 1 up, so it will be 3 to the 1. So x less than 5. Remember, but that's a partial solution. So you'll get x less than 5, but remember that we drew our graph, and this particular function f inverse of x minus 2 has an asymptote at x equals to 2, which means it's never going to touch the line x equals to 2. So therefore, to conclude, that will be x greater than 2 and less than 5. Okay, so that's an alternative way in which you could do it, but we looked at the graph and it was fairly straightforward in that regard. Now let's look at the next question. Oh, this question is now done. Okay, so basically we've covered here sketching of an exponential graph, an exponential function and its inverse, and also looking at a little bit of transformation geometry. Now let's look at another question, and in this particular question we are given here, and once again this is from a past examination paper. I think this came out in 2015 or 2016. Now if you say if you look at this particular question, it says f of x equals to minus x plus 3 and g of x equals to log of x base 2. It says on the same set of axes, sketch the graphs of f and g, clearly showing all the intercepts with the axes. So if we have to look very carefully, we are asked basically to sketch a straight line graph and to sketch a log graph. So let's go and sketch the straight line graph first. So looking at that, sketching the straight line graph is fairly straightforward. So for 6.1, sketching that graph, so what I would do is I would use the dual intercept method, and remember to find the y-intercept, x is equal to 0. Therefore I would say that my y value, this is going to be, if I make that 0, it will be 0 and 3, and my x-intercept is where y equals to 0, therefore that would be 0 equals to minus x plus 3, therefore x equals to 3. So my coordinate there would be 3 and 0. Alright, so I got 0 and 3 and 3 and 0. Let's use this grid provided. So 1, 2, 1, 2, 3. So we'll sketch this graph in black, and this one will be 0 and 3. And my next coordinate that I'm going to sketch is 1, 2, 3, and that will be 3 and 0. 0 and 3 and 3 and 0. So let's look at that. Now let's sketch this particular graph. Okay, so that is going to be the graph of, let's check it out one more time, f. That's the graph of f. So let's have a look at that. That's 0 and 3, 3 and 0, looking at my coordinates. Now let us sketch the graph of g of x equals to log of x base 2. So we're going to be sketching the next graph. Now to sketch the next graph, let us use the calculator as one way in which we could do this. So let's go to table mode and let us type in log. There's your log function there. 2 x is 2, and let's go from minus 5 to 5, and the step will be 1. And let us see. So we got errors. What does this error mean? Error means that function is undefined at all of those x values. So if you look very carefully, we'll be able to see here very clearly that our asymptote is going to be our y-axis, which is at x equals to 0. So we got a coordinate at 1 and 0, 2 and 1, 3 and 1.58, and 4 and 2. So let's look at that very, very carefully. So let's plot our coordinates. So let's plot the first coordinates, 1 and 0 and 2 and 1. So let's sketch this once again in a different color. So 1 and 0 would be there, 1 and 0, 2 and 1, so it'll be 1, 2 and 1. And let's put one more coordinates, which will be 4 and 2. So we got 1, 2, 3, 4, 1, 2. So 4 and 2 will be up here. Now remember that our asymptote is going to be the y-axis, which means that our graph is not going to touch the y-axis. And this is our graph of g of x. So that one is g. And there you go, that is our function log x base 2. Learners, now we've sketched these two graphs f and g. In the second question they are saying write down the equation of g inverse x, the inverse of g in the form y. So let's do that very quickly. So firstly we have once again a log function, and remember that the inverse of a log function will be an exponential function. So let us do that. So therefore 6.2. So once again remember your function is g and it's y equals to log of x base 2. So therefore what's our first step here? So our first step, remember this 2 bumps the y up, so it will be x equals to 2 to the y. Now remember y equals to log of x base 2 and 2 to the y equals to x is one and the same thing. Now the only difference is that with your log function it's written in terms of y. So therefore g inverse would be just basically swapping the x and the y values around. So therefore if you swap the x and y values around, y equals to 2 to the x. So that's your inverse function, or you can write it like this, which is g inverse of x equals to 2 to the x. So y equals 2 to the x, or g inverse x equals to 2 to the x. Let's look at the next question, which is 6.3. Explain how you will use question 6.1 and or question 6.2 to solve the equation log of 3 minus x base 2 equals to x. Now this particular question, let's see, they're saying that we're going to use 6.1 and 6.2. So what did we do? So they want us to use our two graphs that we drew, f and g, and also g inverse of x. So we're going to use those three graphs to actually solve this particular question. So for 6.3, so what we're going to do is let's write the question down and see what happens. So we're going to say log of 3 minus x base 2. So for 6.3, so let's write the question down. It says log of 3 minus x equals to x. Let's see what happens if we try and solve this. So it'll be 3 minus x equals to 2 to the x. And if you look at this, it's minus x plus 3 equals to 2 to the x. So if you look very carefully, you'll be able to see that minus x plus 3 is the graph of f of x, and 2 to the x is what we just found here, which is g inverse of x. So it's an intersection point of f of x and g inverse x. Therefore, it's the intersection of f and g inverse. So if we have to go and look at solving that graphically, it would be as follows. So 2 to the x, the graph of 2 to the x will be, we'll have a one coordinate here at 0 and 1, and we'll have a coordinate at 1 and 2, and the graph of 2 to the x, and we'll also have another coordinate at 2 and 1, 2, 3, 4, so somewhere up there. So basically it'll look something like this. And as you can see, you will have an intersection point at x equals to 1. So the exact point of intersection will be at 1 and 2. So that's the graph of g inverse x. So there you go. You will have that intersection point at x equals to 1. So let's answer question 6.4. And in question 6.4 it says write down the solution to log of 3 minus x base 2 equals to x. And the solution will be, you can write down the full coordinate, which is at 1 and 2, or you could possibly say, if they said at which x value, we'll say at x equals to 1. That is where f and g inverse of x both intersect each other. Learners, this brings us to the conclusion of the series on functions and inverses. And remember to always read first, make a summary, and look at worked examples before you apply any of the theory that you have learned. And if you haven't subscribed to my channel already, please do subscribe to JL Maths and check out the videos on jlmaths.com. And I'll catch you in the next video.